We had someone ask about this question from the 2019 quiz. And in this question, what we're doing is we're setting up a more realistic battery. And so just a little bit of background, so we're, in our class, we're mostly dealing with realistic or ideal batteries and ideal resistors, which is a pretty good place to start. And in a lot of cases, this is acceptable, but there are certain cases where you need to be a little bit more precise and deal with reality. And so what we do here is to sort of model this is we say, well, a real life battery has a little resistance, and we'll call it R. And so we want to look at a question that we've asked before, but now looking at it with a more real life battery instead of an ideal battery. And so the first thing that I'll do is I'll sort of redraw this picture, okay? And so it's just a little bit easier. Now we sort of put this all together in here, but the equivalent to this thing, this thing is equal to this over here. So we have our battery, we have our two light bulbs in parallel with each other, and then I'll just put the resistance of the battery over here. And the question is, when I close this switch, what happens to the brightness of A? And so these choices here are about the brightness of A once you close the switch. And so I think that's the first thing, is to sort of redraw the picture and sort of think about it. And so what happens is when I close this switch, all right, over here, what I'm going to do is I'm going to decrease that resistance. And so you'll see me write sort of things kind of like this sometimes. And so I can take this battery and think about it as, here's a little tiny R, and then this is the R equivalent of A and B. All right, and so what happens is when I close this switch, I add another resistor, and what that does is it actually lowers the resistance of REQ, right? Because I'm giving another path for current to travel through. When we put another piece, another resistor like this in parallel, we're actually lowering the resistance, which is kind of a weird idea. So make sure that makes sense. So the sort of the equivalent of these two guys has just gone down, right? Which means the overall resistance has gone down. And so what that means is the current that comes through here, and I'll just call this the current that goes through little resistor R, right? Well, if the total resistance of the circuit goes down, that is going to go up. And so what we can think then is, well, let's look at the voltage drop across that little resistor. It's going to be that current IR times our little resistance R. Now we assume that stays the same, so if this current goes up, then the voltage drop has to go up too. And then what we do is just something kind of like this. So my favorite battery is a 12-volt battery. And so basically, if I'm going through this circuit, if I come through here, this thing lifts me up 12 volts. And then as I go through, maybe we'll change color just to kind of reiterate what's going on here. So as I go through here, I go up 12 volts. And as I go through these two guys, I should go down 12 volts back down to 0 again and start all over again. And so what that means is the voltage drop across little r plus the voltage drop across either A or B should equal 12 volts. Okay, so the total voltage drop that I do there should equal the voltage of the battery. And so what that means is if this goes up, the voltage drop across both of those guys will go down. And so finally we know that one way to express power is V squared over R. And so if I know the voltage drop across something gets smaller, then the power or the brightness will get smaller too. And so that would give us choice C. All right, hope this helps. Thank you so much.